Nextron's TraceMate II CTR electronic thermostat is designed specifically for control of electrical heat trace. It is a two-circuit controller with each circuit rated for up to 30 amps, 277 volts. The standard unit comes in a Type 4 enclosure complete with two RTD probes. The unit has ground fault trip capability and a comprehensive alarm package. This video will provide an overview and cover basic setup and operation. For the single-circuit TraceMate video, please follow the link in the description. Before installation, please ensure that the ratings on the white nameplate found on the outside of the thermostat enclosure are suitable for your application and power feed. TraceMate II CTR units come in three models: 120-volt single pole, 208-240-volt dual pole, and 277-volt single pole. Applying incorrect voltage can result in damage to the unit. Once the installation is complete, power the unit up. You should see the green Power On LED lit inside the controller. Other LEDs in the same column show the current status of the following: HTR on. The heater is on and drawing current. RTD fail. Problem with the RTD measurement. Low temp. Low temperature alarm. High temp. High temperature alarm. Amp fail. Low current alarm. GF. Ground fault trip. Each LED status, with the exception of power and RTD, is dependent on programmed parameters. You can find default programmed values on the yellow sticker found on the inside of the controller door. If the default set points are changed, write the new values into the blanks provided for future reference. Alternatively, you can refer to the scrolling LCD on the front of the unit. The LCD will run a cycle of information for both heaters. SP1 refers to programmable parameters on the first heater, SP2 on the second. Other scrolling info refers to real-time measured values and statuses for heaters 1 and 2. To program the TraceMate II CTR, you will use a combination of Dipswitch and jumper positions. Jumper positions are as follows: SP, heater set point; amp, low current alarm; GF, ground fault current; HT, high temperature alarm; LT, low temperature alarm. Once the jumper is in the correct position, you will move the dip switch over to the right to program the value you want. The first 9 switches have incremental values from 1 to 256 on the right side. As switches are moved to the right, they add up to give you a programmed value. We will go through programming examples to illustrate this further. Switch number 10 enables you to operate in Celsius when the switch is over to the left, or Fahrenheit when the switch is over to the right. This switch should be in the applicable position prior to changing any values. Switch 11 is used to clear any latched alarms, and switch 12 allows you to select between heater 1 and 2. Each heater has its own settings, status, and measured values, and operates independently from the other. Heater set point programming. The heater set point determines the temperature the thermostat will maintain. This is the only setting that controls when the heater will turn on and off. In this example, we will program the thermostat to maintain 45 Celsius. First, ensure you have the desired temperature scale selected, in our case degrees Celsius, and the switch is over to the left. Place the jumper in the SP position. Note that once the jumper is in any position other than none, the unit will stop cycling through messages and display only the relevant setting and value. Heater set point programming. Move switches with the following values over to the right: 32, 8, 4, and 1. The total sum of these is 45, which is what we want our thermostat to maintain. You can now confirm the setting is correct by checking the LCD. Place the jumper back into none position and push the dip switches over to the left. Low temperature alarm programming. The low temperature alarm setting determines the temperature level at which the thermostat will begin generating a low temperature alarm. This setting does not control the heater, only the alarm threshold. In this example, we will program the low temp alarm at 5 Celsius and below. Place the jumper in the LT position. Move switches with the following values over to the right: 4 and 1. When you add these, the total is 5, which is our desired low temperature alarm threshold. Place the jumper back into none position and push the dip switches over to the left. Low temperature alarm disable. The low temperature alarm can be disabled entirely. This can be useful in applications where the RTD is measuring ambient temperature. Place the jumper in the LT position. Then move the first 9 switches over to the right. This will disable the LT alarm. Place the jumper back into none position and push the dip switches back over to the left. High temperature alarm programming. The high temperature alarm setting determines the temperature level at which the thermostat will begin generating a high temperature alarm. This setting does not control the heater, only the alarm threshold. In this example, we will program the high temp alarm at 64 Celsius and above. Place the jumper in the HT position. Move the switch with the value of 64 over to the right. In this case, no other switches need to be programmed. Place the jumper back into the none position and push the dip switches over to the left. Low current alarm programming. The low current alarm setting determines the amperage level below which the TraceMate II will generate a low current alarm. Please note that for the low current alarm to be active, 2 conditions must be met. 1. The heater must be on and calling for heat, and 2. The current drawn is below the level that is established by this setting. In this example, we will program the low current alarm to be turned off. Place the jumper in the amp position. Ensure the first 9 switches are over to the left. This combination gives us a total of 0 amps and effectively turns the low current alarm off. Place the jumper into none position. Clearing latching alarms. Please note that the low current alarm and the ground fault trip are both latching type alarms. This means that even if the condition that generated the alarm is gone, the alarm will not clear itself and remains in place until the reset dip switch, number 11, has been toggled, as shown here. If, after clearing, the latching alarm comes right back, this means that the condition is still present. It is also possible that your alarm levels need to be adjusted to a more suitable value. Ground fault trip programming. The ground fault trip setting determines the ground fault milliamp level above which the TraceMate II will trip and interrupt the flow of current to the heater. This is the other latching alarm and must be cleared to re-engage the circuit and to clear the alarm condition. Until cleared, the heat trace will not turn on due to the potential of a ground fault. Here, we will program the ground fault trip to be 25 milliamps. Place the jumper in the GF position. Place switches with the following values over to the right: 16, 8, and 1. The total is 25, our desired ground fault trip threshold. Place the jumper back into none position and push the dip switches over to the left. Toggle between heaters. For programming and displaying status LEDs for heater number 2, simply toggle the last dip switch, heater 1/2, over to the right. Follow the same programming steps we've covered for the first heater. Remember, you can always refer to the LCD on the front to check programmed and measured values, as well as any alarm conditions. This concludes our TraceMate II CTR overview video. Please refer to the manual for more details, or call us toll-free.